So there is an important term called the degree of polymerization in the polymer chemistry. So this degree of polymerization it tells you how much chain length is there. So how do you define it? So degree of polymerization is the average number of monomer units in the polymer chain. So we know that the polymer is made up of monomer units. So the average number that is given by the how much number of the monomer unit in average, it gives you the degree of polymerization. Impact on properties. So this degree of polymerization, it plays a major role in impacting the properties of a polymer. So high degree of polymerization means higher molecular weight, it increases the strength, melting point, and also the viscosity of the material. For example, polyethylene. So polyethylene is broadly classified into high density polyethylene and low density polyethylene. So high density polyethylene, the degree of polymerization is up to 100,000, which is rigid and opaque. When it is a low density polyethylene, it's up to 5,000 and it's flexible and transparent. So from this example, it's clear how the degree of polymerization matters in determining the material's characteristics. So degree of polymerization is a critical factor in tailored material design. So it's important to choose the degree of polymerization in an appropriate way. What are composites? So when we go for the composites, they are superior material blends. Their superior material blends means they are even superior to the polymer materials. So they are blended materials. So composites are the materials made from two or more distinct constituents. So it does not contain a single material, but it has different materials. So you have two different important terms that has to be known while learning about the composites. They are the matrix and the reinforcement. So they consist of a matrix. Matrix is a binder, or you can tell it as a continuous phase. And the reinforcement, it's a strength provider, or you can tell it as a discrete phase. So the matrix phase will contain the discrete phase. So discrete phase and this combine to make a composite materials. So what are the superior properties when you see about the composite materials? So the goal is to achieve the properties superior to individual components. So you will have different individual components like polymer or metal or ceramic. For example, if you consider like that, when you join these together they'll give a superior property. That is, there will be superiority in the terms of quality. It will be light in weight, it will have a good strength, it will be more flexible, etc. So concrete analogy. So concrete is an example for with the cement has matrix and the aggregate as the reinforcement. So the global composites market is expected to reach to $130 billion by 2027. So when you consider the example of the cement, it's a good example for the composite material. Types of composites. There are different types of composites. So these composites are made into different or engineered for the different purposes and for good performance. One is fiber reinforced polymers. So FRP, it's called FRP. So high strength to weight ratio. Example, they include the carbon fiber in the aircraft and the fiberglass in the boat hulls. So you can see in the diagram. And particle reinforced composites is the next type. So they have the improved stiffness and wear resistance. Concrete uses sand, gravel, particles, carbon black, It enhances the wear. So the wear resistance is more in the particle reinforced composites. Next is the laminar composites. Laminar composites is just a layered structure. So the layered structure for the specific properties, that is, for example, plywood uses the wood veneers. Sandwich panels have a lightweight course between the rigid skins. So these are the different types of composites. They are engineered for the good performance. Why choose composites? So what are the advantages? Why should we go for composites? So there are different properties that will be enhanced by using the composite materials. They have exceptional strength to weight ratio. They have up to 5 times stronger than the steel for the same weight or 7 times lighter. So we know that steel is a very good material. It is made into different materials and it is also resistant to corrosion. And also it has a light weight than that of the iron and other metals. So we are using steel. So due to this composite materials, they have the stronger than steel for the same weight and it's 7 times lighter than steel also. Next is the corrosion resistance. Unlike metals, they do not rust. It's ideal for the harsh environments. So this is a very great advantages. So corrosion, it gives you the material loss and it also costs a lot. So when it is a corrosion resistant, it's a good material. Design flexibility, it can be molded into complex aerodynamic shapes. So it is very flexible that it can be shaped into any material. Fatigue resistance, better resistance to repeated stress cycles. So this is a very important properties and durability. So longer service life leading to reduced maintenance cost. So economy matters on the whole. So there is everyday applications of the polymer and composites in action. You can see an automotive part, pipe, racket, bottle, Android phone. The material is made up of the composites. How do we conclude this? Materials for a sustainable future. So sustainability is becoming a very more important concern in today's scenario. Sustainability focus. So bio-based polymers and advanced recycling technologies are the key for the future. So it's very important to focus on the sustainability while we are manufacturing the materials and global impact. These materials will continue to evolve addressing global challenges. So we have so many challenges which can be listed. So it is evolved to tackle at least a few challenges. Smart materials. Innovations include self-healing polymers and sensory composites. So self-healing polymers is really a good innovation and glory. Additive manufacturing, 3D printing enable complex polymers and composite structures. So these are the materials that can be made for a sustainable future and this concludes the importance of the polymer. Thank you.